anti-logarithm. Anti-logarithm is another crucial aspect of logarithm that we normally have problem with. So how do we present it to the students in the class? Parents, how can you help out your word at home in their assignment? And the students listening to me, how do you sort out things when you are checking anti-logarithm? Anti-logarithm, as the word implies, is a reverse, an inverse of logarithm. That is, you are turning the number back to ordinary number. You are taking it away from logarithm back to the number. Don't forget the way we have started. When we are checking four-figure table, we determine the characteristics by writing the number in standard form. So the way we have started, we will go back to that one. Then, what is the first thing to know? Standard form to ordinary number. Number 1. 3.74 times 10 raised to power 1. It implies that the power is 1, you shoot decimal point forward because it's positive. 37.4. This is ordinary number. Number 2. 1.037 times 10 raised to power 3. What does that one mean? It means that the number will be shifted forward 3 times. 1, 2, 3. 1037, the point. So we have it in that order. So number 3, when you have 8.9 times 10 raised to power 5. So what do we do in this sense? 1, 2, 8, 9. You discover that there is no more number. You slot in 0. 1, 2, 3, 4, 5. The number of times you have shifted 5 times, then you slot in 0 to replace the holes. So it will now be 8, 9, 0, 0, 0, 0, 890,000. Then the point will now be here. So if you are given 2.574 times 10 raised to power 0, it means that when the power is 0, you will not shift the decimal point forward nor backward. It remains 2.574. That will be the answer. Then number 5, whenever the power 732 times 10 raised to power minus 1, whenever the power is negative and you are writing in decimal point, you shift the decimal point backward with the number of times is 1. That will be 8732. If the point is here backward, this will be 0.8732. When you look at this, we said 0 point. If you shift backward, it will be point. For proper writing sake in mathematics, you start a number with 0 point if there is no significant figure. So number 6, when you have 6.2145 times 10 raised to power minus 4, what do we do? This one is a negative. The decimal point is shifting backward. 2145, it means 1, 2, 3, 4. The point will now be here. You slot in 0. This will now be 0.1236245. That is the way the number is written from standard form to ordinary number. We have to understand this one very well. Number 1, when the power is positive, you shift the decimal point forward with the number, with the value of number you have here. When it is 3, the decimal point is shifted 3 times. 1, 2, 3. That is why it is 1037 point. When it is 5, we shift it 5 times. 1, 2, 3, 4, 5. The point is now here. That is why it is 890,000. Then when the power is 0, the decimal point will not be shifted. You can't have 2 decimal points on a number. Take note of that. And when the power is negative, you shift backward with the value you have here. I have 1 here and it is negative. It is shifted backward. That is why it is 0.8732. And when the power is -4, it is shifted backward 4 times. 1, 2, 3, 4. That is why it is 0006. The 0 here means, for normal pronunciation, 0.00062145. So we have it in that order. So let us now see the application of this one in our anti-logarithm. To do the anti-logarithm, we must have seen a situation whereby we have the excess of logarithm. Take for instance, if we have the number log and you have a number, you now come with 1.3456 and you want to check the anti-logarithm of this. Take note, anti-logarithm of this. Anti-logarithm of a number is checked in terms of a decimal places, not in terms of significance. Then the decimal number here will be considered in the 4-figure table. And how do we check it? The decimal here, the decimal number is 0.3456. 0.3456. Then antilog, check 30.34 under 5. You check 0.34 under 5. 0.34 under 5. Then add difference 6. So we go to the anti-logarithm table. 0.34, you will see it there. 0.34 under 5. 0.34 under 5. That is 2213. 2213. Add difference. Add difference 6. Under that one, difference 6 is 3. We add 3 plus 3. So we now have 6122. After checking this, where will our point be? 2216. Where do we put our point? Take note of one important thing. When you are checking the anti-logarithm, we only consider the decimal part. Why this part is not touched? Then what is the function of the excess of the characteristics here? When we, after checking, this number will now be written in standard form. 2216. It will now be in standard form. It will now be 2.216 times 10 raised to power what? You will now export the one here to the power of 10 raised to power 1. The one will now, anything here, if 0 is here, it will be raised to power 0. If 2 is here, it will be raised to power 2. If minus but 1 is here, it will be raised to power minus 1. Then this one will now be right as ordinary number. Power 1 will now be 22 points. The decimal point will be shifted forward 1.16. That will now be the answer. The anti-logarithm of 1.3456, we check this 0.34 under 5, add the difference of 6. When we check, it is 3. Then when we get it, the number will now be written in standard form. The excess of the characteristics will now be the power of 10. Then the number will now be converted back to the ordinary number. Let us see another example. So when we have our number log, we have checked, we have done, and we have bar 0.4218. So then anti-log, check 0.42 under 1, add difference 8. So we go to our anti-logarithm. 42.42 under 1, it is 2, 6, 3, 6, 2, 6, 3, 6, 2, 6, 3, 6. We have 2, 6, 3, 6. Then add difference of 8. We go there, we go under the difference. Difference of 8 is 5. We add 5. So it will now be 11, 4, carry 1, 6, 2. Then the number will be written in standard form. 2.641 times 10 raised to power. What will be the power of 10? The 0 here will be the power of 10 raised to power 0. So when it is power 0, the decimal point will not be shifted. The answer is 2.641. Let's see one example more so as to understand this. If you have checked the number and the log, let's say you have checked, you now come with bar 2.0057, bar 2.0057. How do we check this one? I have told you that to check anti-logarithm, we check in terms of the decimal places. The first 2 decimal places, irrespective of the number that is there, 2 decimal places under the 3rd decimal place, then you add the difference of the 4th decimal place, unlike logarithm. So what do we check? This one will be kept as we have seen it before. Then what do we check? Check under the anti-log, check 0.00 under 5. Then add difference 7. So we now see 0.00 under 5. That is 1012. 1012. Difference of 7 on that line. Difference of 7 is 2. We add. This will now be 4101. Then the number will now be written in standard form. And to write a number in standard form, the 4th digit, 1.014 times 10 raised to power, what is the excess here? The excess here will now be bar 2. When we are writing it the other time, when it is negative, we write it as bar. And when it is bar here, we write it as negative minus 2. And when this one is being written in standard, in ordinary number, the decimal point will be shifted backward. 0.0114. 0.014. That will be the final answer. On this note, I want to employ all our teachers taking basics 11, especially at this time around, and SS basic 11 of SS2 to follow this normal procedure, and those of us taking basic 10 or SS1 follow this procedure of determining the characteristics and the mantissa and how the anti-logarithm must be written in a proper order without confusing the student and ourselves in the class. Welcome to Faith Educational Consult class. I'm Bankole Joseph. We want to see some example using logarithm table and checking anti-logarithm. Example 1, evaluate using table 541.3 times 34. So we draw the line, number, log. So 541.3, then 34. So what is the characteristics of this one? As we have learned, 541.3 is 5.413 times 10 raised to power 2. So characteristics is 2. When the number is expressed in standard form, 34 is 3.4 times 10 raised to power 1. So characteristics is 1. We will now check the 4-figure table. 54 under 1, difference 3. 54 under 1, difference 3. 54 under 1 is 7332. 7332. Difference of 3 is 2. So we add it together. It will now be 7334. And 34, to check this, we say 34 under 0. 34 under 0. And 34 under 0 is 5315. 5315. Then we are going to add it together. We should add it together. 4 plus 5, 9. 3 plus 1, 4. 3 plus 3, 6. 7 plus 5, 12. Then we take one bundle of tens to this place, plus 1. 1 plus 2 plus 1, that is 4. So we have it as 4. Then we now check the antilog. Antilog. What are we checking in the antilog here? We check 26 under 4, difference 2. 26 under 4, difference 9. 26 under 4, difference 9. So what are we going to check? When we check 26 under 4, our 26 under 4 in the antilog is 1837. 1837. Then difference of 9 is 4. So when we add 4 to 1837, it's going to give us 1841. 1841. Then it will not be expressed in terms of standard form. 1.841 times 10 raised to power, the excess here 4. So it will now write it as ordinary number. It will not be, we shift the decimal point forward 4 times 1841. 0, 1, 2, 3, 4 point. So the answer will now be 18410 point. That is the answer. Going to the second example, we draw the line. Number log 72.82 divided by 4.34. 72.82 divided by 4.34. So what we need to do is to write this one in standard form, equals to 7.282 times 10 raised to power 1. The characteristic of this one will be 1. Power of 10. 4.34 will be 4.34 times 10 raised to power 0. The characteristics will be 0. Always ask the student to write it in standard form and pick the power of 10 as the characteristics. In this, we are going to subtract. We are now going to check the four-figure table. 72 under 8, difference 2. 72 under 8, difference 2. 72 under 8 is 8621. Difference of 2 is 1. When it is added, we have 8622. 43 under 4. 43 under 4. So when we have, look at 43 under 4, we have 6375. 6375. So what we need to do here is to subtract. And when we are subtracting 2 minus 5, we come here, we take away bundles of tens. This one becomes 12. 12 minus 5, that is 7. So we come here and this one becomes 5. And this one remains 1. When we borrow bundles of tens to it, becomes 11. Becomes 11. 11 minus 7, 4. So 5 minus 3, that is 2. 8 minus 6, 2. Then point. 1 minus 0, 1. Then we check the antilog. Antilog. So what do we check in the antilog here? 22 under 4, difference 7. 22 under 4, difference 7. And what is 22 under 4? 22 under 4 is 1675. Difference of 7 is 3. When it is added, we have 1678. 1678. Then we now write it in standard form. 1.678 times 10 raised to power the excess of 1 here of the characteristics raised to power 1. Then it will now be written back in standard form, which is 16 point, the decimal point will be shifted forward once, 16.78. Let us look at example 3. So when we have this 0.432 times 71.23, so we have, what is the characteristics of 0.432 when it is written in standard form? 0.432 equals to 4.32 times 10 raised to power minus 1. This will now be bar 1. And what is the characteristics of this one? We also write it in standard form. 71.23, which is 7.123 times 10 raised to power 1. This is 1 point. Then this will be added together. Take note, write it in standard form, pick the power of 10. And we have said when the power of 10 is negative, it will now come to a bar, bar 1, bar 1. So what is 43 under 2? We check the four-figure table. 43 under 2 is 6355. 6355. And 71 under 2, difference 3. 71 under 2, difference 3 is 8527. 8527. When it is checked in the four-figure table. So what do we do here? We add it together. We add them together. 5 plus 7, 12. 2. 1 plus 5 plus 2, 8. 3 plus 5, 8. 6 plus 8, that is 14. We add 4, then 1 will be carried. When we are dealing with the negative number, we have to be very careful. This is minus 1 plus 1, then the 1 we carry plus 1. So this will now be minus 1. We cancel, it remains plus 1. So the answer here will be 1. Then we check the antilog. Antilog. The antilog of 48 under 8. 48 under 8. Then we check the difference and add it to it. 48 under 8 is 3076. 3076. Difference of 2 is 1. That one will now be 3077. 3077. Then we will now write it as standard form. That one will now be 3.077. The excess of the characteristics will be the power of 10. So it will now be 30.77. Then we come to the last example here, which is number log 0.0028, 0.78. What is the characteristics of this one? We write 0.0028 equals to 2.8 times 10 raised to power 123 minus 3. This will now be bar 3 points. And 78, 0.78 will also be 7.8 times 10 raised to power minus 1. This is bar 1. We are going to subtract. So bar 28 under 0. When we check 28 under 0 in our 4-figure table, we have 28 under 0, which is 4609. 4609. So 78 under 0. 78 under 0 is 8921. 8921. We have to set the number in order. 1 under 9, 2 under 0, 9 under 6, 8 under 4. Ditto to other problem. We have to arrange it in order. So we are going to subtract 9 minus 1 is 8. This is 6. This one remains 5. This is 10. When 1 is borrowed, which is bundles of 1, becomes 10. 10 plus 0 is 10. 10 minus 2, 8. Then this one remains 5. We come here to borrow. This one remains 1. So this one will now be 15. 15 minus 9. 15 minus 9. That is 6. So this one remains 3. Then is it possible to borrow 1 from bar 1? Yes. When you borrow from bar 3, it turns to bar 4. The idea is this: when you borrow 1 from a number, you subtract 1. That is, I borrow 1 from minus 3. I must subtract 1, becomes minus 4. So this one will now turns to bar 4. Bar 4. So we now have bar 4 clearly written. This is bar 3, turns to bar 4. So this will now turns to 13. 13 minus 8. 13 minus 8. That is 5 point. So bar 4, it remains minus 4, minus 1, minus 4, minus 1. We have minus 4 plus 1 equals to minus 3. Look at the work here. This one, we borrow 1 from minus 3. It turns to minus 4. If 0 is here, it returns to minus 1. If minus 1 is there and you borrow 1, it turns to minus 2. If minus 2 is there and you borrow 1, it turns to minus 3. Now that we have minus 3 there, you take away 1. You borrow 1 from minus 3, it turns to minus 4. it is possible to borrow from number, any number, either positive or negative. When you borrow, you shift backward. When you borrow, you subtract 1. So now that we borrow 1 from -3, we take away 1, which is -3 minus 1. It turns to -4. -3 turns to -4. So when we now subtract 1, -1 from -4, it will now be -4 minus -1. -4 minus turns to plus, becomes +1. So -4 plus 1 becomes -3. So we have bar 3. Then we check the antilog. 56 under 8, difference 8. 56 under 8 is 3698. Difference of 8 is 7. So it will now be 3665. 3665. 3765. Sorry. 3765. So what do we now have? 3765. So we now have 3. We write it as ordinary standard form. 3.765 times 10 raised to power -3. So it will now be, the decimal point will be shifted backward. 65. 1, 2, 3. So the answer is 0.376. 0.003765. 0.003765. 0.003765. So that is the way the simple problem can be approached, and the simple problem can be explained in this way. So in the next video, we'll try to see some other problem in applying indices, logarithm, and anti-logarithm to solve mathematical problem. Thank you.